Hello to my differential equation class. Okay, lesson 31H is solving systems of equations using Laplace transforms. So we are going to pretty much combine lesson 27 about Laplace transforms and lesson 31C about solving, C, D, one of them, about solving systems of equations. And yeah, we're just kind of melding the two together. So about the only things that are different is now we have to take the Laplace in terms of y and the Laplace in terms of x. And so before, when we did the Laplace transforms, it was always capital Y of s. But now we're going to have some capital Y's of s and other capital X's of s. But then we're going to use the process that we did in solving systems of equations. The nice part about these is then we don't have to go back and reconcile the arbitrary constants, because these do have initial conditions. Then when we solve the Laplace transforms, then the initial conditions are already figured up in there. And so these don't get quite as long. They're still long, but they're not quite as long as just the solving systems of equations. Yeah. So as always, if you guys have any questions, let me know. Using Laplace transforms to solve systems of differential equations. Okay, so we've got this example, dx dt equals x minus 2y, and x of 0 is negative 1. dy dt is 5x minus y, and y of 0 is 6. So the first thing we have to do is transform both of these into using Laplace transforms. And so if we do that, then this one becomes s capital X of s minus x of 0 equals capital X of s minus 2 capital Y of s. And this one becomes s capital Y of s minus y of 0 equals 5 capital X of s minus capital Y of s. So just like when we were doing Laplace transforms before, the next thing is to go ahead and plug in our initial conditions. So this now becomes negative 1, and this now becomes 6. So once we do that, let's pull the x of s's together first, and then the y of s's, and put the constant to the other side. So if I have x, capital X of s, then on this side I have s, and when I move this term to the other side, I get minus 1. And then I can pull my y of s over, and then my plus 1 here becomes a negative 1 over there. Okay, so let's do the same thing for the what was the original, dy dt. So I have a negative 5 x of s plus y of s. I now have an s plus 1, and this now becomes a positive 6 to the other side. Okay, and so these are the two differential equations that we will, or the two Laplace equations, I guess, that we will come back to a couple of different times. And so first thing, so now we're going to get into the solving systems like we did back in 31D. And so we're going to find one of the two and decide to eliminate it. So let's eliminate x first, just because. I'll do that one in black. Eliminate x of s. So let me rewrite it just because. ys2, and then xs negative 5, and ys s plus 1 equals 6. So in order to be able to eliminate x, then this top row will have to get multiplied by 5, and this bottom row will have to get multiplied by s minus 1. So when we do that, xs 5 times s minus 1, and ys is 10 equals negative 5. And down here we have sx is negative 5 times s minus 1, and y of s is s plus 1, s minus 1, and we get equals 6 times s minus 1. Okay, so when we add those two lines together by the elimination method, because we have a negative 5 and a positive 5, then these cancel out, and we have pulling the capital Y to the front, 10 plus s plus 1, s minus 1, and on this side, negative 5 plus 6, s minus 1. Okay, let's pull this up here a little bit. So now, doing some algebraic simplifying, if I go ahead and FOIL this out, I have s squared minus 1 because the middle terms cancel out, and on this side 5 minus 6s minus 6. So y of s is s squared plus 9, and I have a negative 6s minus 11. That doesn't seem right. This should be plus. That should be minus. So that should be positive. So y of s is 6x minus s minus 11 over s squared plus 9. Okay, well, I don't have, looking at my Laplace tables, I don't have anything that has that matches this form, but I can break this into two fractions just by breaking the numerator into two fractions, the two terms. And then I look at it, and looking now, this looks like, from our table, this looks like number 8 with a being 3, and this looks like number 7 with a being 3, except that on top I need to have, right here, I need to have a 3 instead of an 11. And so in order to fix that, I can put a 3 on top, but if I put a 3 on top, then I have to put a 1/3 out in front. So once I do that, then now doing the inverse, so now I have a lowercase, and we're doing of t, this becomes the 6 becomes my coefficient, and I have cosine of 3t, and then my 11 joins my 1/3, so I have an 11/3 sine of 3t. And that's the first half of the problem. Now we get to go back, and you can do substitution if you want to go back and substitute this in order to figure out what x is. I'm going to go ahead and do elimination again, and so I'm going to, let's eliminate y's, and I'm going to go back to kind of these equations, and so I'm going to rewrite these and eliminate y's. So let's do that. So eliminate y of s. So again, we are here kind of rewriting things. Times 2 equals -1. And xs -5 plus ys s plus 1 equals 6. So now if we want to eliminate the y of s, that means that the top one has to get multiplied by s plus 1. And the bottom one, let's multiply that by -2. So when you multiply that out, you get sx, s minus 1, s plus 1, plus y of s, 2, s plus 1, equals a negative s plus 1. When you multiply the -2 times the bottom, xs, you get 10 plus ys, -2 s plus 1 equals a -12. So now when we add those together, now the y's cancel out, and if I factor out the x of s, then on this side I've got s minus 1, s plus 1, plus 10. And on the other side, a negative s plus 1 minus 12. So okay, let's do again some simplification. So if I FOIL this out, I get s squared minus 1 plus 10. And on this side, negative s minus 1 minus 12. So y of s is s squared plus 9 again, and negative s minus 13. Okay, let's take this up here. So that means y of s is going to be a negative s minus 13 over s squared minus 9. And again, just like the other one, I can go ahead and split this up into two fractions. And so a negative s over s squared minus 9 minus 13 over s squared minus 9. And again, these is 8 and 9, formulas 8 and 9 from the Laplace tables that I gave you. 8 and 7. From the Laplace tables that I gave you. And so this one, because it has the s on top, does not need to make sure that the a matches. So I've got a negative cosine of 3t. Y of t. Nope, we're not in y's, we're in x's. Ooh, all of these should be x's, because we eliminated y. So this is x of t. But here, again, I need a 3 on top, which means I need to put a 1/3 in front. So now my coefficient for that is 13/3 sine of 3t. So my overall answer is x of t is negative cosine 3t minus 13/3 sine of 3t, and my y of t that we got before was 6 cosine 3t minus 11/3 sine of 3t. And the nice part now is that now we don't have to go and find those arbitrary constants, because we've already done that, and that is our answer. If you guys have questions, there are lots of videos on this, and so I encourage you to search some other videos, but you're also welcome to ask me questions.